or will be done early. So one option for us is kind of step through the final exam, the practice final exam. Don't get excited, not the actual final exam. Or so we can kind of do that if you want to. If you have any specific questions from like the last test, because those corrections are due in the day of the final. By the way, just to reiterate this, I don't know if I've said this recently. If you never made corrections to quiz 1, for example, you still can't. You're not going to get as many points back as you could have, but if you get enough of them right, you might get a point or two back, right? They're kind of late. They're a little bit late. But again, the final's cumulative, so I want you to have a reason to do anything that's going to get you more prepared for the final. So if you never did chapter 2 homework, which is our first chapter, that's the one we started at because I don't know how to count, right? So of course I should teach this class. So chapter 2, we started with chapter 2. If you never did the homework, you could do it. Turn it in. It's a little late, but it's better that you'll get more than a 0, right? So where do you guys want to look at? If nobody's saying anything, the floor is yours, right? I don't know if students ever believe me when I say this, but I brought like nothing, planned.
I had a question.
Yes.
Number 9 on the practice test. I was trying to do it today and I just kind of got
Where did I put here we go. 9. Oh, the GCF?
Yeah.
Okay, all right. Let's take a look. Oh boy, I got a wider range of colors. Okay. So this was GCF 540, 300? 540, 300. I specifically say using the subtraction method, right? Thankfully, you don't want to do this with the prime factorization method. Good Lord, no. All right, so really good, even if you forgot what that means, you pretty much can intuit that you subtract the numbers. But I don't know if anybody remembers why this works, but we talked about it quite a bit about it's sort of related to the multiples. If I subtract any multiples of 3, I will end up with another multiple of 3. All multiples of 3 are a multiple of 3 apart. Does that make sense? Okay, all right. So if you just start subtracting, what I've just effectively done is I've said this GCF is equal to the GCF of 240 and 300. And now you kind of reset because now the bigger one is 300. So now you're going to take 240 away from it. So now the GCF of that is equal to 240, 60. At any moment, you can stop and say, okay, I see the answer. So it's kind of a hint here. Do you guys see the answer? 60, because 60 goes into 60, and 60 goes into 240. So there must be the greatest common factor. Since this equals this, and the biggest thing that goes into both of those is 60, I'm done. Maybe? But officially, if you did keep going, if you subtracted 60 a few times from this, you'll eventually get to 60. So then it would be GCF 60, 60. And then it's really freaking staring you in the face, right? But anytime you can just see the answer, you stop. That's the whole point of subtraction, is to get you to a point where you can actually just see the answer. At the beginning, I can't just see the answer. I don't know. Is that cool?
Yeah.
And of course, that led to the division process because division is just repeated subtraction. So that makes sense. That would be the next way to make this more efficient. Okay. I lock it in my key. So again, review days are always, or the way I do them anyway, is it's all up to what you guys want to focus on, right? So we're going all the way back to chapter 1 and 2 for this final. It's going to be cumulative, so anything can show up. I think I can't remember if I said this, but you've got your practice final look at, but you've also got all the old practice tests and the old tests, for example. Because I'm not going to give you a problem that's completely out of the realm of a type of thing I've given you before, right? They're all going to involve the same concepts. So for example, I think normally the thing that people have the most trouble with is chapter 1. Do you guys remember chapter 1? Problem solving, right? And it's understandable because it's exactly like word problems in algebra. We're just not used to thinking the way that you need to for those. I'm not going to ask you a question like, list all of the strategies. We sort of did that together last time, right? But do you remember there's the problem, the person planting the strawberry plants or whatever it was, they had to be so far away from each edge and so forth, right? So that's a chapter 1 kind of problem, right? So I'm just trying to give you guys ideas of where we might want to focus. Did I put a chapter 1 kind of problem on here? I can't remember. Oh, am I looking at the wrong? No. Okay. Bump, 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 bump. Not really. Look at me being nice. Well, sort of like number 1. Yeah.
Oh, I was gonna say something.
What's up? What you got?
21.
Oh yeah. Okay. So 21. I actually did it on the practice, the answer key. But what was up with 21? That was from number 21 on the practice final. Yeah. And you're like, there's a number 21 on the practice. Yeah, this thing's kind of long. That's from that chapter that we made extra credit, or that I made extra credit, right? So.
There's like 221, so are they both?
Oh, I see. All right. There is 221s. And again, going back to my earlier comment, I don't know how to count. I'm not sure why they let me keep going. Was the question about the first 21 or the second 21? The first one? Okay, good. The last 21, and I like the number 21 because I was born on the 21st, I guess. That's why I like to put 2. That's from chapter 9. We talked a little bit about square root stuff. I'll probably put at least a bonus question on the actual final. Number 21 is asking you what's the sign of the answer, right? I think either we've gotten used to the smell or it's cleared out. I don't know.
Was that just asking if it's positive or negative?
Totally. Yep.
Oh, okay.
Yeah, I don't care what the answer is. I just want to know, will it be positive or negative? So how do I tell that real quick for this problem? What was it? Can you guys tell me? I don't care what the number is. This piece by itself, is it going to be negative or positive? How many negatives do I have being multiplied? 5. Every pair of them are going to do what? We try not to flick you guys off. Every pair is going to cancel, correct? Every pair is going to cancel. If I have an odd number of negatives multiplying or dividing, the answer will be odd because you'll have an odd guy left out. You'll have an odd guy left alive. Stayed out of the finding, right? So this will be negative. 11 is positive. So negative 3 to the 9th, based on what I just said, it's going to be negative. It's going to be a negative value. The 8 negatives cancel. They pair up. And then the 1 negative is left alive in the end. So what is negative times positive times negative? Negative times positive times negative? Positive. So the answer is going to be positive. I don't care what the number is. I just wanted to know, is it going to be negative or positive? Okay. Let me ask this again real quick. I think a few more people just came in. Anybody still need a practice final? Huh? Yeah. Hold on. Let me see. Oh, shit. All right. Everybody, yeah. Anything else? Yes.
On the final, are you gonna give us like a key for like the Egyptian?
Yes, totally. So like I said last time, I'm going to give you the exact same thing I gave you before. So I gave you the Mayan base, because that's the one that's a little weird. I gave you the Roman numerals, and I gave you the Egyptian numerals. Yeah. I'm not going to ask you about ancient Chinese numerals. That was a problem in the homework. It's not going to be on there. Okay. You have to know the Babylonian base, the Babylonian numerals. What about the Mayan numerals? What were those? Big breakfast, yeah. Pancakes and blueberries, yeah. So you got sticks and dots, right? You guys all with me? Babylonians we talked about was Pac-Man and stick, right? A lot of sticks in the ancient times, so that makes sense. Yes?
Do we just buy the regular Scantron?
No Scantron. So let me tell you guys this. If you ever have a math teacher that uses Scantrons, they are not a math teacher. I don't know what they are. Because what's the most important thing in mathematics? If you're a teacher, what's the most important thing? Work. Scantron, and I'm not coming down. I understand. But Scantrons are the antithesis of work, right? On both sides. It would be so easy. Oh my God. If I could just give multiple choice, just feed the damn machine, I'm done with grading. Oh my God. That would be so nice. But no. Okay. Yes?
Can you go over like converting to a different base?
Yes. So real quick, I'm going to do a teacher trick. I'm not going to answer your question first. I'm going to answer it second. Why is it nice going from a different base to our base? Why is that the nicer option for translation? Does anyone remember what the hell this means? What base am I in? Fifth base, base 5. So what are these places? What's this place? Right? 5 to the 0, 5 to the first, 5 squared, 5 cubed, which is exactly what our base system does, because our base system is just one option. So it's going to act like any other would. What does ours do? 10 to the 0, 1. 10 to the first, 10. 10 squared, hundreds place, thousands place, right? Every base is going to do the exact same thing. We just happen to choose 10. I don't know why we chose 10. So I need you to understand this. Some people will always do these things backwards. This is already base 5. These places are filled in. They're not empty. So I got 125 plus 4 25s plus 2 5s plus 3. I mean, that kicks ass. That kicks ass, right? So what if instead, and whatever the hell that adds up to be, I almost don't care. What if I had 1423 and I want to convert it to base 5? Yeah, so the places are empty. So let's see. I have the 1's place, 5's place, 25, 125. What's the next one up from there? How do you find it? You just take 125 and multiply it by 5. 625. Does everybody agree if I multiply by 5, I'll get 3,000 something or other? 3125. So do you see how that's too big? Do you remember me saying always go too far? To make sure you went far enough, verify the next step is too far, right? What operations did we do on this problem? Multiply, add. So now I'm doing the inverse of that. So I'm going to expect to divide and subtract, yes? So who remembers the first step here? I'm trying to take the number 1423 in our base. How do I know it's our base? I don't know if 1423 is base 10. Because there's nothing there. We don't write 10 because we're 10. We're not going to write that. It's just a normal number to us. What's the first step?
To see if 1423 is able to go into that first one that you gave us. multiply into it.
Other way around. So can 625, how many 625s go into 1423? So how much of 1423 can this place take care of? Two of them, right? Twice 600 is 1200. Does that make sense? So if I put 2 here, how much do I have left? What is twice 625? 1250, kick ass. So how much of that number do I have left to worry about? 173. The way I'm saying this is the way I look at it, which is I've got this much of a number to take care of. This place, 2 of them takes care of this much, so these places have to take care of this much. So 125. One of them can take care of that much, so now how much do I have left? 48. Do you guys see what I'm saying? So this is harder than this, but it's not hard because it's still one of the 4 basic functions: addition, subtraction, multiplication, division. 25, I can only use one of them because 2 is too many. And then I have only 3 left. 5, I can use 4 of them. And then I got 3 left. Which numerals can you not have show up here? Anything bigger than, anything that's 5 or up, right? Anything bigger than 4, because base 5, just like base 10, there is no numeral for the number 10, correct? So, of course, whatever base we're working in, the number below that is the highest single digit. So base 10, 9 is our highest single digit. Base 5, 4 is our highest single digit. Okay, I like it. Okay. So the way to write this would be 2, 1, 1, 4, 3, base 5. Kick-ass. Yes?
Can you do 7 on the practice test?
Oh, yeah. The one about divisibility?
7, sorry.
7, yeah. On the practice final? Or on the
On the practice final.
practice final? Let me make sure we're looking at the same thing. Right, the one about divisibility?
Oh, this 7, the first
Oh,
7.
okay. Again, yeah.
Oh, that's 7.
So the first 7, all right. Obviously, I think I added that and forgot to change all the numbers. Or I just don't know how to count, which, is concerning. Okay. So the difference on this problem is now we're in base 12. So the highest single digit in base 12 would be, I need a highest single digit that I need is for the number, so number 11, right? So I need single digits from 1 up to 11. So again, the book uses T and E, which is dumb, right? I think we all agree, maybe. It should just be A, B, because then it's consistent. Because hexadecimal uses A, B, C, D, E. What does A mean then? 10. So when I go to do this, I'm in base 12, correct? The places are not empty. So therefore, what do I have in the ones place? 10, good. See, now when I start to write my number like this, I've identified the places in a different kind of way. I would never write this as this because then it looks like it has 4 places. Okay. So now I've identified that's the ones place, I could put 10 there. And then here's the 12's place, I got 6, and then what's this? 144's place, I got 1. And now you just got to multiply and add. So whenever you're starting at a different base, coming back to ours, that should be relatively easy. It's just multiplying and adding, right? The other way, of course, is the other way, dividing and subtracting. Okay, yeah.
How did you get 10 again?
So I really want this to make nothing but sense. We have base 10, meaning the number 10, the numeral 10, it was 1, 10, 0, 1s. It needs 2 digits, correct? Base 12, if we had one more finger, we would almost definitely have base 12. We would just grow up in it. Base 10 would be the weird guy. Okay. So base 12, I need single digits up to 11. Same way in 10, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, rolls over because that's the base. So base 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, we need to create a digit for 10, and we need to create a digit for 11 because it's not supposed to roll over until 12. Does that make sense? Okay. So again, the book said T&E for 10 and 11, which again, is dumb. Just use A and B, right? And again, it's just a choice we had to make in history. We could have chosen it to be happy face. We could have chosen it to be peace sign. We could, we just needed a symbol that meant 10. Okay, I like it. So if there would have been a B there, that would have been 11. Kick ass.
So for sure, like when you give us test, A is gonna be 10, B is gonna be.
For sure, yes. I like it. And you can add, you can actually make little words and such like cab base 13, or something, All right, I like it. Yes.
Can you give them
By the way, you do one of these plus 6 of these plus 10 of those, right? Okay. Number 1? Oh yeah, right? Okay. All right. Number 1, of course, is one of my favorite problems on there. I want to show that every odd number can be expressed as a sum of 2 consecutive counting numbers. What the shit? Sorry. Do you guys remember, how would I represent every even number? If I wanted you to write down something that represents every even number, not a sentence, I want a little thing that represents every even number. What's the underlying property of every even number? It's divisible by 2, correct? All right, can you write me a number that's divisible by 2 that like if I just write this, do you know if that's divisible by 2? I don't know. So how do I make it really obvious that it's divisible by 2? There's every even number. And I can't remember if I told you guys, but the letter N, normally when you see that in mathematics, it represents a natural number. Those are the numbers that came naturally to us. 1, 2, 3, those are natural numbers. So when N is 1, what's this? When N is 2, what's this? 4. I'll generate all the even numbers here. So this represents every single even number in existence. If you want a specific one, just figure out what N to shove in there. Leave me alone. I'm done. I wrote them all. So what do you guys think about every odd number? Be really careful. I'll have students say 3n. Is that right? No. 3 times 2 say that's not odd. Yeah.
2n minus 1.
Okay, 2n minus 1 or 2n. We'll do this. You could do that, but let's say plus 1, just because. Okay. Because if n was 1, 2n minus 1 would be 1. That's right. Do I want it to be that? Yeah. Okay. Let's do this. That'll be even. That's fine. It actually doesn't change either way. I just realized I didn't start at 0. I started at 1. Okay. Now, so that is every odd number. That is part of this problem, right? Show that every odd number can be... Okay, I just wrote every odd number in existence, correct? Focus on the second part of that sentence. What does consecutive mean? Can somebody give me an example, just a specific concrete example of 2 consecutive counting numbers?
3 and 4.
3 and 4, holy shit. Give me another one, another pair.
24, 25.
24, 25, holy shit. So what's the relationship no matter what pair you're going to give me?
N right next to each other.
Now tell me mathematical relationship.
N and then N plus 1.
Yes. So you can either do n and n plus 1, or if the bigger number's n, what's the number that came before it? So n minus 1, 11. So this is what I was saying when it doesn't matter if you put a minus or a plus there, you just got to be a little careful. Somebody agree with me, those are 2, either one of these would be 2 consecutive counting numbers. And what does it say I'm supposed to do with those? Sum them. What do you get when you add these together? n minus 1 plus n? What's n minus 1 plus n? What's n plus n? 2n. So this would be 2n minus 1. Does that look familiar? Totally. So I could have done it this way. You could think of this concretely. Somebody give me an odd number, any odd number. 3. How do you add two numbers to make 3? 1 plus 2, correct? All right. What about 87? That's odd. Right? So what is 87? Isn't 87 43 plus 44? This isn't a proof. This is just getting a feel for what the problem's even the freak talking about. You guys sort of with me? Let me ask you this. If I add two even numbers together, is the result odd or even? Even. If I add two odd numbers together, now think about it, is the result odd or even? Even. Right? Try it. Okay. If I add an odd and an even together, the answer is always odd. Consecutive counting numbers. Won't one be even and one be odd because they're offset by 1, right? Okay. So all that stuff is related. So the key on this problem was realizing there's two components to this. Every odd number, the sum of two consecutive numbers. And then if you can write both of those, you can show that they're equal to each other. Now, if I would have written 2n plus 1, that would have been the sum of these. Right? Still works. Okay, maybe. Y'all look very excited about that one, which is, standard. It's normal. You're not used to representing everything in the universe with one expression, right? Yes?
Can you go over scientific notation?
Yeah. Did somebody have something else this year? Okay. Scientific notation. How would I change each part of this problem into scientific notation? How would you figure out this guy in scientific notation? So it's going to be, you got to move the decimal until it gets to where? Right after a single digit, right? So I'm going to move the decimal how many times? Good. So it'll be 4 times 10 to the negative fifth. Good, because if I made it positive, it would actually become a big number. It's supposed to become a small number, negative. Small number, negative power. Big number, positive power. Much better than left and right, especially for me. What about this dude? I need to move the decimal until it's between what? 2 and 1. So how many times do you have to move it? Yeah, 3, 6, 9, 12. Right? 2.1 times 10 to the 12th. I like it. Right? So I could give you a problem just about translating into scientific notation or out of scientific notation. More than likely, I'm going to give you a problem like this where you have to do both and then go ahead and multiply them out. How the hell do you do the next step?
You could do like 4 times 2.1.
Yeah. 4 times 2.1 is, you're not distributing, you're just commutativity, right? Everything's multiplication, so I can just move things however I want to. What's 4 times 2.1?
8.1.
Holy shit. And then how many tens do I end up with?
7.
And I'm done. Look at that. Look at that. Yeah.
Would you take that as an answer, or do you need actually do it?
If I don't say, I would accept this. Normally I'm going to say leave the answer in scientific notation but if I don't say and you translate that into like numerical form, I'm not going to take points off. Yeah. Yeah.
Number 17 on the practice test.
Now on the actual, if that was a problem on the final, I need you to understand I would have said at the end, why? Because otherwise you got a 50-50 shot. Right? Yes or no? So I'm going to want a why. But what's your first, is that enough though? I'm sorry, about scientific notation. Okay. What's your gut tell you about this? So I say A is 20% less than B. I say that is a fact. Does that mean that B is 20% more than A? And the trick here is 20% does not equal 20%. It doesn't. 20% is of something. So let's give ourselves some concrete numbers. So what if A is 10? I'm sorry, the way this is written, let's see. Let's say B is 10. A is 20% less than B. Yes? How would you figure out what A is? So how do you figure that out? So this is exactly the same as the shirt's on sale for 20% off. What's the sale price? It's exactly the same problem, yes? So how much, so two steps. How much do I subtract from 10? I don't know yet. But how do I figure it out? How much am I going to subtract from 10? I'm going to subtract 20% of 10 from 10, right? Or if it's 20% less, that means there's 80% of it left. That's 8. (20% of 10 is 2. 10 minus 2 is 8. The shortcut is, if I take 20% of something away, what percentage of it is left? 80. So 80% of it will be left. Okay. Now, try the other way. Now we're asking, is it true that B would be 20% more? What should I say? A is 20% less than B. Is B 20% more than A? So what's A? What did we figure out A was? 8. How do I figure out 20% more than that? A couple ways you could do it. So to figure out B, I need to figure out 20% more than 8. So I'm going to add something to 8, correct? How much am I going to add to 8? 20% of 8. So I'm going to take 8 and I'm going to add 20% of 8 to it. What's 20% of 8? 1.6 plus 8, 9.6. Did I make it all the way back up to there? No. So real quick, an example I normally give when I'm teaching percentages is, let's say that I make $20 an hour, right? And I get a paycheck and they cut my pay by 10%. You guys with me? Can somebody figure out how much I'm making now? Sweet. Right? You with me? Let me keep up with what I just said. Okay. I go and complain and like, oh, we're sorry. We'll increase your pay by 10%. We're sorry. Am I okay with that? No, because now when they cut my pay, what they take 10% of? 20. And that got me to 18. If they're going to increase my pay by 10%, aren't they taking 10% of 18? That's never going to make it all the way back up. Does that make sense? So this is what I meant when I said this earlier, and this might have sounded weird to you when I said it. 20% does not equal 20%. You can't say that. It depends on what it is of. Yes? If I donated 20% of my salary to something, and then Bill Gates donated 20% of his salary to something, are those equal? Hell no. And you're like, we don't know you, Jeff. Well, you would hear about me if I was anywhere near that. Okay. All right. Is that better? Now, the really interesting thing about this problem is this is not a proof problem. I didn't say prove something. I said, what did I say? Where'd it go? What number is this again? Thank you. if A is less than is good. So you can actually use a counterexample. So this would be a valid way to answer my question. No, it isn't. Here's a counterexample. So if it's true, it has to always be true. So to show me it's not true, you just have to show me one place it's not true. Okay, maybe. Okay. Let me ask you one weird question. Is there ever a time this is true?
Well, if it's from like, so you were saying like your pay like 20, starting at 20, if it went like, I guess back to 20, like if your employer was saying, oh, it's gonna go back to 20. And
So then the percentage would have to change.
Yeah.
Okay, so I'm saying keep the percentage the same. That is never true except for one case. The what's called the trivial solution.
When B equals 0?
When they're both zero,
Yeah.
right? If A and B are both zero, then that's just silly. Anyway, I'm sorry. Didn't mean to do that. Okay. So this actually is always untrue unless I make nothing an hour and then I get my paycheck and I'm like, wait a minute, you cut my pay by 20. No. Sorry. Okay. Sorry. We'll give you 1,000 times as much as you normally get, Jeff, which is nothing. There you go. Is that all right, guys? Is that all right? Real quick, I'm almost certain that you don't want this, but just in case. If I always forget which way this goes. If A is 20% less than B, so that means A is 80% of B. Is everybody with me? If A is 20% less than B, then A is 80% of B. It says, is B 20% more than A? So is B 20% more than A? Just in case you were curious if there's a way to do this without just a counterexample. The counterexample is the way I would go. Is everybody with me on this? 20% more than A would be 100% of A plus 20%, making it 1.2 times A. That's like we did the problem where if it was a markup, you add. If it's a discount, you subtract. You guys semi with me? So watch what I can do. If these are both supposed to be the same, that's what it's asking me. I could solve this one for A. And then see if it's the same as this. What is 1 divided by 1.2? 1/12, so it's point. Yeah. 833. Yeah. So is this the same? Are these the same? Nope. So we actually just proved it never works unless A and B are 0. Or unless A and, well, even then, no. They have to be 0, yeah. Okay. All right, sorry. That was a little too much. Okay. Where we want to go next? Anything else? So you can ask questions from the last test. You can ask questions from the practice final, homework. Yeah.
16.
So I sold the car at a profit of $500, which was 12% of the selling price. Okay, good. Remember the problem we did where it was a little bit extra work because, so if I said a hat is on sale for 10% off, it now costs $20. What was the original price? That's more work. Because to get to the sale price, I took 10% of something I don't know. This problem is nice and straightforward. It tells me $500 is 12% of the selling price. That's what it says, right? So can you write that as an equation? 500 is 12% of I don't know. We don't know the selling price, correct? I don't know if you guys are with me. So if you read it, it says, I sold a car at a profit of $500, which was 12% of the selling price. What's a more efficient way to say that? 500 is 12% of selling price. So how do I write 500 is? Let me write it up here. So 500 is 12% of selling price. And this is what we don't know. 500, what's is in mathish? Equals 12%. Change it to an actual number. What is it? All right, or 0.12. Of means multiply. Selling price, I don't know. And then solve it. Now you could, if you wanted to, you could do the is over of thing, right? You could do that if you want to. A few different ways to do this. How would I solve that for x? Yeah, divide by 0.12. And whatever the hell that is. Man, that was almost so 4,166.67. We'll round it for like a okay. Thing about percentages is very often they're rounded. So if you're trying to work backwards with a given percentage, you're probably going to get a number that doesn't make exact, concrete, everyday, real life sense because we've rounded stuff. Did I do it? Oh, there was one problem I said I was going to do in class. Yeah, number 20. Number 20. That's a relatively new problem. Can you guys do number 20? I didn't put it on the key, so we'll do it right now. Has everybody got the practice final? Number 20. There's only one number 20, so we all talk about the same thing. Yes?
Did we finish 16? Are there 2 parts to it, or is it just?
Yeah. It was that number, 4,000, whatever. Yeah. So it was a very cheap car. Yeah. Well, probably really old car. So number 20. Can you guys do that? If you don't have colored pencils, you just use little pluses and minuses, right? So this is where we would use the colored chips. Yes? Okay. Can you represent that problem? So the way that we see this is very different from the way that somebody just learning this stuff is going to look at this. I have 5 negatives, and this is asking me to take away 6 negatives. That's a fundamental problem, correct? That's like if I have $5 and you want me to give you $6. I can't do it, I'm sorry, right? So what do I start with? What's the picture look like to start with? What do I have before I do any operation? What do I start with? What's the beginning? I start with 5 negatives. It wants me to take away 6 negatives. So there's a nifty little thing we're able to do. Which was what? Make a 0. And of course, negative, positive equals 0. So if I just put negative, positive, I've done nothing. It felt like I did something, but I've done nothing. But now am I able to do what this thing wants me to? Yeah, I could take these 6 negatives away. So then what am I left with? One little positive all by himself. Does that match up with what we would get computationally? What would minus and negative become? This would be -5 plus 6. And what's -5 plus 6? 1. Sweet. Right? And this is really trippy. I mean, none of us remember necessarily doing this. And I'm not even sure, to tell you honestly, how they necessarily taught this to us way back when. This is quite a long time ago. So we don't think this way automatically, but this is the bridge between somebody getting used to counting stuff to work with numbers, and they don't know the computational approach yet. So they're still in the stage of counting stuff. So if you want me to take away 5 trucks and I only have 4 trucks, we got an issue, right? Okay, maybe. Okay. Is that all right? So let me do this. I'll do this. I'm going to give you guys the answer key here, right? Before you head out. Sure. Double check me. I'm averaging about a 97. I think that was the only one. Yeah, okay. I did everyone else, okay. What is up there? No idea what that is. Okay. Okay. Trying to make sure I didn't leave anything undone. So I did the second 21, but again, that's not something you're going to be expected to do on the final. Victoria, right? Did you get? Yeah, you got the. Yeah, you got the practice final study guide. Did you get those? Yeah. Yeah, so 4,460 miles every 6 months. How far will you have driven after 2 3/4 years? Okay. So 4,460 miles every 6 months. So unit-wise, what's the issue? There's an issue with units.
Months versus years.
Yes. So the question's all about, okay, you know this, so 2 3/4 years, how far will you go, right? So how do I take care of that problem? There's 2 ways you could do it, but
Change the 2 3/4 years into months.
you could, or if I double this, doesn't it become per year? So either way, if you change the years to months, you actually lose that fraction, which is kind of nice, right? So it doesn't matter which way you go. I don't remember which way I went. So which way do you guys want to go? Okay, so if I double this, that becomes 12 months, which is a year. This becomes 8920. So now, this kind of problem, you would need to set a proportion, blah, 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 but not really. If I drive 8,920 miles per year, how many miles do I drive in 2 years? 8,920 miles a year. How many miles do I drive in 2 years? Double that, yeah. How many miles do I drive in 3 years? How many miles do I drive in 2 3/4 years? Yeah. So this will be 8920 times, change this into improper. What's this become? 11/4. 4 goes into 8920. Then you can multiply by 11. This feels like a problem I would say, do this without a calculator. So 4 goes into 8920. Let's see. 2, 2. That'd be 88, 12, 3, 0 times 11. A really nifty way to multiply by 11. I don't think this has come up this year, which is weird, or this semester. Whatever the hell time unit we're in. 2230 times 11 is 2230 times 10 plus 1. So, I mean, it's sort of come up with the idea of distribution. What does that do for me? Well, what's 2230 times 10? Yeah, you add a 0. Plus 1 times this. So that's nice. So multiply by 11 kicks ass. You just multiply by 10 and add 1 more to the original. That's multiplication by 11. So you get 24, 5, 30. Is that what past Jeff got? I always worry about past Jeff. Which problem was it? 18, okay, thank you. Hey, look at past Jeff go. Good job.
Can you go over what a rational number is?
Say again?
Can you go over what a rational number is?
Sure. Irrational numbers are just numbers that cannot be written as fractions. So they would be stuff like, the big ones are pi. Has anybody ever heard of E? Not the letter E, but the number E. You gotta love math, people. The number E. Well, if I say number pi, you guys are cool with that, right? Even though pi is a letter. Okay, so there's a number E. It's used in exponential growth and decay and such. So if you've never heard of it, you're fine. Then you also have like square root of 2. So any decimal that doesn't repeat and doesn't terminate. Right? Terminate. So if it goes forever and it has no pattern, it is irrational. It cannot be written as a fraction. Because we've done a couple times the process. If I give you something that has a pattern, we've done the process to figure out what the fraction is. You guys remember that? We've done that a few times. Okay. Is that all right? And again, I'm not going to get too in depth because that was like a whole extra credit part. Like chapter 9 is all extra credit. Yeah.
The homework or like?
Yep, chapter 9 is extra credit. Because I'm crazy. Yeah, the only thing really important from chapter 9 was the radical idea, cube roots and square roots and so forth. Yeah.
Can you go over 21?
Which one? The second 21?
Yeah.
So again, the second 21, right? The one with the radicals, the one with the square roots. I just really like the number 21, so I used it a couple times. You see that?
I only see 121.
That's all right. So the one with the square root.
Like the last problem.
Yeah, the last problem. I got you. So again, this would be a bonus question, right?
No, the other 21.
Oh, the first 21. Okay. So now you see what I'm talking about. So we did that one earlier. If I have an odd number of negatives, what was it? Fifth power? Was it 9? 3. If I have an odd number of negatives, every pair does what? A pair of negatives, when you multiply, they become positive. This pair becomes positive. What about this negative? Still there. So if I have an odd number of negatives, is still negative. Right, so that's negative. That's positive. What's this one going to be?
Negative.
Negative, because we got 9 negatives. And what's negative times positive times negative?
Negative. Positive.
Because the two negatives kill each other, right? I like it. So real quick, guys, negative 1 to the 1148. What is that? In fact, you could tell me the number, right? It's positive 1. Because there's an even number of negatives. Is that cool?
Yes.
Okay. Or understood, I guess I should say. It's hardly ever cool, Jeff. I understand. Yes.
Can you calculate mentally with decimals?
Yeah.
Well, like, can you show, like, for example, the 42.13 minus.
Oh, all right. Oh, yeah. Okay. What was the other part of it? 4213?
Minus 29.99.
What is that number so close to that, oh my God, if it was it would be so cool? How far away from 30 is this? 0.01. It's like a penny away, right? So the whole idea of subtraction is it's telling the distance between two things. So if I make this one 0.01 bigger, the distance is not the same as it was, right? So I've got to make the other one 0.01 bigger. So if I make this become minus 30, I've got to make that become 42 point. Add a penny. Those two have the same answer. This one sucks. There's a lot of borrowing, right? Sucks. This one kicks ass. Could I do that with like 81.73 minus 29.98? Of course. Now I'm going to add how many pennies? 2 pennies to both, right? So it doesn't have to be right on the cusp. It just has to be closer to it, right? So you can do that with all kinds of stuff. Kick ass. Yes?
Can you also do, like, the number range? Like for a fraction, like 7 divided by 1/2.
Oh, okay. That's not a problem from there. What about 5 divided by 1/4? I like it. Right? So 0 to 5. 1, 2, 3. You can do it, Jeff. 4, 5. Right? So 5 divided by 1 is 1, 2, 3, 4, 5. I've already broken it up into a certain number of ones. So the first step to do 5 divided by 1/4 is to break everything up into fourths. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so now how many fourths are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Do you see that? How many 1/4 fit into 5? That's what that's asking. And this is what I meant earlier. The number line, if I just do this, I'm breaking it up into ones. So how many ones fit in 5? Frickin' 5. But if I want to know how many halves fit in 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 divided by half is 5 times 2 is 10. That is a physical representation of why we reciprocate the second dude when we divide. Maybe. You're welcome. Yeah.
Can you do, on section 7.4b, number 36?
No. I did bring one. Okay. If you add, okay. If you add the square of Tom's age, so what do you want to call Tom's age? Let's call it T, right? call it uppercase T. Which one was it again? I'm sorry. Which one was it again?
Number 36.
Thank you. There it is. If you add the square of Tom's age to the age of Carol, Carol's age, incredibly enough, I'll call that C, right? Where'd it go? There's. The sum is 62. So if you add the square of Tom's age to Carol's age, you get 62. That's what I got so far. Is that cool? And then it says, man, these people must be really bored sitting around Tom and Carol. If you add the square of Carol's age to the age of Tom, the result is 176. I'm curious. Determine the age. So they want to know the actual ages. Can you right now, without doing any work, tell me who's older? Totally. Because when I square her age, the number at the end gets stupid big, right? Poor little Carol. So they want me to figure out the ages of both. Where'd it go? There it is. Okay. So how could I figure that out? So we could apply some techniques. We could try guess and check. That might make us go a little insane. But to be honest, guess and check is still kind of gross because there could be a lot of different things, right? So what else could you try to do? It's a little weird this is in the percentage section. I'm trying to figure out what they want. Algebraically, what I would do is I'd solve for C and then plug it in here. But, that's not what they want us to do. Plus, that would actually be kind of gross. So you could try to do guess and check. Let me think. What's another way we could do this? Yeah, if you try to just try a few things out. For example, real quick. So Carol's obviously older, right? So I can rule a few things out real quick. Could Carol be 40? Because Tom would have to be 22. That's not a perfect square, right? So I know T squared has to be a perfect square. Yeah.
Could you find the nearest thing that can be square rooted? So to 62, 49?
No, because this is a sum. So it's not really, that's not going to give me an idea what that is. These are added together, so it's not just depending on the square part.
Yeah, so 7 squared plus C. You understand?
Yeah, totally. So you could do it the other way around. That's what I'm saying. So don't start with Carol's age, start with Tom's age, right?
I don't know, I feel like
So if Tom is 7, Carol would have to be how old? That would be 49, right?
Yeah.
So then Carol would have to be 13. And then you can check there. So there's a few checks and balances. Carol's older, for one thing. That this has to be a perfect square, so you can start with that to see what ages Carol could be. And then you can kind of try it in there. I'm trying to figure out why they put this in the percent. I'm not sure why they put this in the percent section, to be honest. But that's the way I would do it, is to just try a few things out, because you'll see how you're getting closer and closer to the right answers. This feels like it should belong in chapter 1. Maybe. I'm not going to give them that benefit of the doubt. Now, there could be something about it I'm not thinking about. It doesn't really seem to me to be a percentage problem. Oh, okay. So yeah, guess and check's not a bad way to go. Yeah.
Can you go over 11B?
Oh, yeah, I think looking at my key, pretty sure I set that up sideways. Remind me real quick, 2 times 3, how do I set that up? So if I want to do the rectangular array method, dude, So it'd be 2 rows with 3 columns, right? Get out of there. 2 rows, 3 columns. Okay. So if I have, what was it, 4/5 times 1/3, the second dude should be here. So my answer key, I actually did 1/3 times 4/5 for whatever reason. So to do 4/5 times 1/3, this should be 1/3. How do I represent 1/3?
Shaded in one.
Good. And then 4/5 will go this way. So 1, 2, 3, 4. And then how do I represent 4/5?
Shaded 4 across.
Yeah. And yeah, you could shade these, but you know, what's important is you end up with 4 out of 15. Yeah, yeah. Which of course is the right answer computationally, but that's how you do it visually. Yeah.
We do 14.
All right, so Miss Keebler. I love it. I love it, Jeff. Miss Keebler. Yeah, so a recipe would make enough for 3/5 of her class, and there's 45 students, so 3/5 of her class would get cookies, and there's 45 students. So if she follows the recipe as it is, she'll be able to give cookies to 3/5 of her class, right? If she makes 2 batches, how many students could get more than 1 cookie? Well, if 1 batch makes enough for 3/5 of her class, 2 batches would make enough for 6/5. Yes, right? If 1 batch makes enough for 3/5, 2 batches makes enough for 6/5. Makes twice as much, right? So 6/5 of the 45 students could get a cookie. Now, obviously, real quick, guys. Obviously, 6/5 is more than 100%. Well, how much extra? Exactly how much extra is there? 1/5. So there's 1/5 of 45 extra cookies. So 2 batches makes enough for 6/5. That's 1/5 above everybody. So 1/5 of 45 is? What's 1/5 of 45? 9. So 9 students could get more than 1 cookie. How did past Jeff do? Yes, of means multiply, yes? Past Jeff did good. All right, good. Yes?
Wait, so was the final test is on Tuesday, right? Or Thursday?
Tuesday.
Okay.
Yeah.
And then what's Thursday?
Thursday doesn't exist for this class. Our class ceases to exist after the final exam. So I could have given you the final on Thursday, but I decided to let your break start early. So hopefully that's okay. If you want to report me, feel free. Technically, I'm supposed to give us the final on the last day of class, but yeah.
When do you get the results of the final?
I'm gonna probably get them done that evening. I'm gonna post them. I'm not sure how long it's gonna take the update. So what I normally say on the day of the final is email me anytime you want to, and I'll email you back with the results when I'm done, if you want. Yeah.
So if this is all the homework turned in, that's the highest. Wouldn't this one be higher because this is test 3 corrections done and homework turned in?
Yeah, that's weird. Why'd that happen to you? Ah, scheisse. I gotta double check my calculations.
So would they be flipped?
But did you take a makeup for test 3?
Yeah, this is the makeup.
Ah, that's what happened. I input your grade, and then I have another field that's like, what would happen if you made corrections? And I didn't. That's blank, I bet.
Oh.
So it should have been 100. If you make corrections in this, though, you'll get 5 points back, right? And then that would make that higher. Okay, that explains it. I was worried I made it wrong for everybody, but for you specifically, I just forgot to put in what your grade would be if it was corrected. So then this is calculated on a blank space. Yeah.
So do
Okay.
you know what this would be if it were like...
Off the top of my head, that normally, let me think. So what did corrections do? So made it go up by 0.5. That. Oh yeah. Okay. So this would. Oh, off the top of my head, I don't know. Sorry.
Okay.
If you email me, I can let you know.
Okay.
Yeah.
Thank you.
For number 10, you have like, I think an extra 3. So would that change the answer? Because it's like 3 times 3 times 5. Because 3 times 3 is. I think you like thought that it was 3 plus 3.
I love Past Jeff. He's a good guy.
It would
That's
just change
hilarious.
slightly, right?
Yeah, it would. Yeah. What was I thinking?
But then down here you put 3, 3. So maybe.
Was I doing that like? Did I add
think you
that
were
later?
Yeah, because that's what I was showing Natalie. I was like, he probably did 3 plus 3 plus 3.
So this should be 3 through 5, and this is
Yeah.
this. So then there should only be 2 3s in the answer.
Yeah.
Yeah. So that would be 1/3 of
One-
this.
Yeah, yeah.
Yeah, I have
It's
no
not that
idea
serious,
how I.
But I
well,
was just making sure that in my head.
it's a little serious for me.
I did have missing work. Are you just no longer taking it in, or
Say? What?
I do have a bit missing, but
Yeah, it's interesting. Why did I say none? Shouldn't be true.
I'll just
Yeah, I agree with you. I think you definitely have some missing. I'm
Yeah.
not sure.
I
And again, I'm manually typing this stuff in, so it's really possible my eyeballs went to the wrong. I'll have my spreadsheet on the day of the final, and we can double check. If you want to know what you're actually missing, just email me. I could tell you.
Yeah. And you said 8 homework is extra credit, or is it 9?
9.
9.
9.
Alright.
Yeah.
Okay. You know how much it'll be, or like?